Hello everyone. In this video, we'll start to understand what is abstract class and interface, what differentiates them, and in what situation we'll choose one over the other. Let's understand the core semantics and the purpose of both of them. Abstract class represents and is a relationship. It establishes an inheritance hierarchy. Think of it as a parent child relationship. For example, dog and cat are animal. This implies that it shares the traits, that is eat, sleep, that all animals have. So subclasses inherit a common structure and behavior. Contrast it with a interface which represents a can-do relationship. That is, interface defines capabilities a class can adopt regardless of its inheritance chain. The most common example of inheritance of interface is serializable interface, which when an object implements can be serialized. Here we see a user class or a document class which are unrelated by inheritance. Both implement this and get the capability of being serializable. The key point here to understand is that interface is all about behavior contracts and not hierarchy. Now, abstract class is used when we want to generalize the behavior, which means that abstract class can share code, fields, methods across the subclasses in order to reduce redundancy. An example would be an animal abstract class, which defines a name field, a breed method. Subclasses such as dog and cat can inherit these and add more specific information, for example, calling bark or meow, according to what the class is. The key point here to understand is the base class provides templates for subclasses to build on. Contrasting this with interfaces, we use interface when we want to standardize the behavior among unrelated classes. For example, in this code snippet, we see that there is a cleanable interface with clean method. Both the robo class and car wash class implement this interface. So both classes can be treated as cleanable objects. So when we create classes of robo class and car wash class, they can be treated as cleanable objects, enforcing this standard behavior. Now, when specific requirement is present, abstract classes can both be used can be used to include both concrete methods as well as abstract methods. Concrete methods means fully implemented methods, and abstract methods means with no implementation. Here in this example, we see that animal class defines the breathe method concretely but leaves the make sound method abstract, forcing the class cat or dog to implement accordingly. The key point here to understand is the subclasses must fill in the gaps for the abstract method, whereas interfaces provides a contract without implementation. Here we can see that the cleanable interface defines the clean method, and the robo and the car wash implements the clean methods in their own entirely different ways. So interfaces enforce what a class can do and not how. Last but not the least, multiple inheritance is not allowed in abstract class to avoid the complexity of multiple classes, whereas interface provides this flexibility of uh, implementing multiple interfaces or multiple contracts. Now, choosing between abstract class and interface depends on whether we are designing an inheritance hierarchy, which is a relationship, or a capability, which means a can do relationship. Now, after understanding the purpose and semantics of them, let's focus How about the key technical differences between them? Now, interfaces have undergone a major change post Java 8, but technically the purpose remains the same. We'll discuss their differences based on the features. With respect to method implementation, abstract class can have both abstract and concrete methods, whereas interfaces prior to Java 8 has only abstract methods. Post Java 8, default and static methods have been allowed to add new functionality to the interfaces without breaking the existing code. Now, interfaces still cannot have instance variables as it defines a contract, not a state. Hence, even constructors are not allowed in interfaces because constructors are the ones which initialize the instance variable. So, having a constructor would in interface would actually uh, be meaningless, whereas in abstract classes it continues to have instance variables and thereby it continues to have constructors as well. As we know, with respect to inheritance, single inheritance is allowed in abstract classes and multiple inheritance is supported in interfaces. With respect to access modifiers, methods can be public, private, and prior to Java 8, in interfaces, the methods are public by default, and post Java 8, default static, and even post Java 9, private methods are allowed. The important point to note here is Java 8 onwards have blurred the traditional boundaries by introducing default static methods in interfaces. So before Java 8, interfaces couldn't share code, but now they can. So abstract classes can still uniquely support state, that is fields, constructors, and non-public methods, and interface remains stateless contracts. They can't enforce how a class initializes dependencies. Now moving on to understand when to use what. Now choosing between an abstract and class and interface, we have some key questions to ask or consider. The first being primary, what is the primary purpose of using or building such a design, whether it is to build a contract or whether it is about implementation. So when you're building a contract, one would prefer using an interface, and when we are thinking about shared code or state, we'll go with abstract class. The next question we need to ask is whether we have a shared state or common code. If multiple classes require common fields or method, then one can lean towards the abstract class. Whereas if one needs only pure definition without any state, then interface would be ideal. We have to consider about inheritance restrictions as well. Since multiple inheritance is allowed in interfaces and not allowed in abstract class, this is also an important question that we have to consider while designing. Now, what about default implementation? The default implementation is obviously there in abstract class from the very start, and post Java 8, default methods also include the common piece of code that we need to add that we can share across the interfaces. So this reduces the need for an abstract class. In case of cross hierarchy implementation, the interface suits the scenario most because unrelated class can implement the same behavior. Now, last but not the least, with respect to future extension and maintenance need, we have to understand whether we have to understand the fact that interfaces support more flexibility and decoupling, whereas abstract class simplifies the scenario with related implementations. Now moving ahead with a real world case to understand why we have chosen an abstract class or why or could we have chosen an interface in what scenario? Now we take a case of a class called abstract Amazon SQS consumer, which is at the top of this hierarchy. The CRM fetch consumer and CRM push consumer are classes which inherit from this base class. The base class defines the high level flow for processing an SQS message. And as we can see here, it holds shared fields and methods such as SQS client and QURL. SQS client being of the type Amazon SQS, and QURL is which is something which connects to a specific queue. Now we also have a constructor here which initializes this field. Process message is something which is kind of a template method, and it has the following functionalities. It validates the message, it calls an abstract consume method, which is defined in this base class, and it also deletes the message from the queue if all goes well. Now, this consume message is something which we will see when we come to this point, that they are both inherited and implemented accordingly by the both the consumers, fetch consumer as well as push consumer. Now, there are other methods in this base class, like validate message, which kind of provides some default logic, get attribute value, which extracts the value from SQS message, and a handle message, which calls the process message if for some condition like the body is non-empty or something of that sort. The concrete implementations that we see here, the fetch consumer and the push consumer, they implement their own domain specific logic, and they can also provide special implementations wherever necessary, like the message consumption and optional validation if it's needed. Now, the question comes here, like why we chose an abstract class in this scenario. The point here is to understand is that we have shared fields like SQS client of type Amazon SQS and QURL, which we wanted to initialize with the constructor. They are both present in this base class. Then we had this requirement that this process message method had some kind of partial implementations, which means that they had certain steps that had to be executed in order for consistent process flow. The process flow I've mentioned here, the validates the message, calls the consume message, and deletes the message. So this process flow had to be followed for all the consumers. Also, the message, the process message we have defined as final in this base class, for the fact that we don't want the both the consumers to override them, but follow the steps that are there. So this will ensure that for processing message, always same steps will be done in same order. Now, abstract class, choosing an abstract class provided us the template to carry out all the above requirements. Hence, abstract class was used in this scenario. Now, coming on, now here I've also provided the sample code for the base class as well as the consumer class. Example of both the concrete consumer classes which implement the base class. One can have a look at it later. Now, moving on to the real world example of interface. This class, called email validation event consumer, is implementing a message listener in interface, and when it implements this message listener interface, it implements a method called on message here, as we can see. Now, the reason why we chose an interface in this case. So we have chosen an interface in this case as it defines a clean contract without forcing any implementation details. In this scenario, we don't have
A state, like unlike in the case of abstract class, it's not needed. So we just wanted a pure behavior definition, and that is the reason we went with an interface. Plus, this choosing an interface also provided us the flexibility. That is, it allows the class to implement multiple other interfaces or contracts if needed. This is the sample code for this if one needs to look. Now, moving ahead with the best practices. So, there are some guidelines or best practices, as we would call them, when we are designing. The first one being that we favor interfaces for decoupling. Now, this means that when we program to an interface, we should program to an interface rather than a specific implementation. This principle will kind of give you the flexibility and make the code easier to maintain, extend, and test. For example, when we declare a variable or a method parameter as a list, in this case, we are not committing any implementation like an array list or a linked list. The abstraction here would mean that the code only cares about the behavior is defined by the list interface and also gives us the flexibility to change the implementation that suits our need. Now, the other thing is that we should use abstract classes when subclasses need shared state or non-public methods. The third best practice would be to implement both. In this case, we see that the bird class, the abstract bird class, implements a flyable interface. That means we are trying to reuse the flyable's default methods while adding a bird-specific logic. Whenever we use either interface or abstract class, it is recommended that we use @override annotation for clarity in both the cases. So another pro tip is that we should use interfaces for public APIs and abstract classes for internal code reuse. Now, these all these are kind of theoretical. Let's try to understand how do we implement them. That is the best practice implementation. As we mentioned just now, that we should use interfaces for public APIs and abstract classes for internal code reuse. Interfaces define what a component can do, that is contract, and abstract define classes define how a family of related component does share its code. Combining them both gives us the flexibility of interfaces with the code reuse power of abstract classes. Now let's see this with an example. We have an interface called payment processor. Okay, it has a method called process payment. This has just overlapped. It also has a method called get transaction ID. Now, it's recommended that in order to utilize this interface for best practices, we should initially create a abstract class, say base payment processor, which implements this interface. What this abstract class will do is it will give you the flexibility to add logger methods or utility methods or methods which have to be shared by the which can be shared by the concrete implementations. So if we see here, we have some common validation logic in this validate amount. This process payment is the method we are obtaining from the payment processor. We leave this as abstract. We provide certain default logic in the get transaction ID. So we are implementing one, but we are leaving the other class as other method as abstract. This method implementation will be provided by the concrete classes which implement this base class. So here, if we see, we have a first implementation as Stripe processor, which provides the implementation of this process payment and also has the flexibility to uh, use the common methods like validate amount, or if needed, it can also provide its own implementation of other utility methods like getTransactionID if required. The other implementation that we see of this base class is providing its own specific logic for process payment. Now, there can be also a third-party vendor which implements this public interface, and it can simply go and use this use implement these two methods with their own custom logic. There can be another team which focuses on business logic, which can focus on the business logic like a internal bank processor, which extends this base class and provides its own implementation of the process payment method. And it can just simply use the boilerplate code which is given in this base class. So what key benefits we see with this kind of implementation? One thing we see here is the public API stability. Since the third party depends only on this interface, it can continue using this interface without any breakage. Then we can update the base class which was implementing the interface and add new logging without breaking any external code. Then we definitely see a code reuse here. All the internal processors can inherit validation logging or transaction ID handling. If we need to add another payment method, just like Stripe processor, PayPal processor, or an Apple Pay processor, it gets all the base logic with it, plus it can extend the process payment and provide its own specific logic. The main thing that we see in this kind of implementation is there is separation of concerns. Like interface is defining what the system must do, abstract classes defines how a group of component does it, and concrete class shows how to implement specific details. Now we conclude this presentation with the evolution in modern Java. This is important because post Java 8 we have seen very important changes happening in Java with respect to interfaces. Now Java has introduced default methods which can provide default implementation for methods. This is important for backward compatibility, which means that adding new methods to interfaces without breaking the existing implementation. For example, in the list interface, a sort method was added as a default method. So all existing implementations like ArrayList, linked list automatically inherited this. This also reduced the boilerplate code, which means common logic across all the classes was put there without forcing the other implementation to rewrite them. Default methods we can say is that they have blurred the line between interfaces and abstract class. Now interfaces can include both static methods, also static method, which means like the utility or the helper functions. Why this is important is that all the interfaces related logic can be kept inside the interface only. For example, the comparators interface natural order static method creates a comparator for natural ordering. Plus, there is no need to create any separate classes to host the static methods. The other major change that happened was with respect to functional interfaces being introduced, which can be implemented by via the lambda expressions. Now, this kind of enabled the functional programming to write concise and expressive code. Post Java 17, sealed interfaces were introduced to restrict the class or interface to restrict which classes or interfaces can implement them or extend them. This kind of controlled the inheritance and enforced stricter domain modeling. Security-wise, they also prevent unauthorized implementations. Now to summarize the evolution in modern Java. Now modern Java has transformed interfaces from simple contracts into dynamic reusable components. They support code sharing, by default static and private methods. They support functional programming via lambdas. They support control design via sealed interfaces introduced in Java 17. Now that brings us to the end of this video. Hope this knowledge was useful to you and help you design better flexible systems. Thank you.